Welcome to lecture 5.3. Alright, so now we're looking at graphing trig functions. So we are already introduced to sine and cosine, and we're going to focus on just those two right now. So sine and cosine, we're going to focus on graphing those two trig functions. First off, we have the unit circle. And remember, we have the different points on the unit circle. And or at least it was defined, that the sine, or sine, is the y values, right? All of the y values on our unit circle. We correspond each of those y values to a certain radian value. So for example, for pi over 6, the matching y value is a half, and those would be the sine values. The next thing we did, or the next thing in the definition, was we went ahead and corresponded all the x values with the function called cosine. Now what we're going to do is we're going to graph this. We're going to graph this relationship. So once again though, for pi over 6, cosine is related to root 3 over 2. That's sine, and cosine is the other one. Let me squeeze that in. Cosine. Okay, so we're going to go ahead and work with this and graph these. So I went ahead and we have all of our different values from the unit circle right over here. These are all the values from the unit circle. We're going to go ahead and write down the matching sine values, or otherwise we know sine is once again the x values, sorry, the y values, and cosine are the x values. And we'll go ahead and write those down. For the sake of graphing it, we're going to find approximations because, let's say for pi over 6, the matching value is root 3 over 2, and that's hard to graph. What are the other weird values that are hard to graph? Well, another one that's hard to graph is root 2 over 2. Other than that, we know how to graph a half. A half is just equal to 0.5. And then 0 and 1, we can graph those numbers easily. So for approximating purposes, and once again, if you ever approximate, please use the approximation symbol. So root 3 over 2 approximates to about 0.9. And then root 2 over 2 approximates to about 0.7. So we're going to use this for graphing. One thing to note, when you graph, you can approximate, but when you give an answer, unless otherwise stated, you should give the actual value. So if you were answering for a problem, you would answer with the root 2 over 2, unless you're told to approximate or round off, and then you could possibly round off to, let's say, the 0.7. So, let's see. For sine of t, at 0, sine is 0. At pi over 6, sine is a half. And at pi over 4, sine is root 2 over 2, which for graphing, once again, we are going to be using 0.7. Let me go ahead and write down all these values. Feel free to pause the video, write them down yourself, and check in with me in a second. Alright, so I went ahead and filled in those values. So now, let's graph sine function. So what's thinking the sine function is pairing the pi value on the unit circle, or the radian, or the distance. So it's pairing this value here with the y value on the coordinate. That is what sine is doing. So now we're going to go ahead and graph that. And before we do that, let me go ahead and mark this up with some of the values we would need for our graph. So we start at 0. And we end at 2 pi. And then in between 2 pi and 0, we have pi. And then after that, what do we have? Well, we have pi over 2 here. And then in between those two, let's see, pi over 2 pi, 3 pi over 2. I'll go ahead and leave it with these for now, okay? Those are the main values I would mark down. The next thing to think is, how are the y values? What's the highest y values I get? Or sorry, the highest sine values. The highest I get to is a positive 1 and a negative 1. So positive 1, negative 1. Let me go ahead and mark that. Positive 1, negative 1. Now let's go ahead and graph sine. Once again, we're just looking at the y values relating to the pi values, or the t values in our case. So at 0, 0, right there, let me go ahead and label that 0, 0. Next we go up to pi over 6, half. Well, I don't have pi over 6 down, so let me go ahead and label that. Pi over 6 is, it's going to be pretty rough, about here. And then in between that, we have pi over 4 and pi over 3. A little squishy. Okay, so we have pi over 6, half. Okay, so that goes up to about here. It's halfway. Let me go ahead and label that on my graph too. 0.5, negative 0.5. So that would be pi over 6, half. And then we have pi over 4, should be root 2 over 2. But remember, root 2 over 2, we said we can approximate to about 0.7. So close to 1, but not quite at 1. Goes up to about here. Oops, wrong color. And then we have pi over 3, which is at 0.9. Still not quite at 1 yet. And then we have pi over 2, which hits 1. Pi over 2 and 1. That 1 is a little off. Let me bring that down. That's a little off there. Waiting for my pen to catch up. Alright, so we have our values there. So this is the first part of the curve. It goes up, it hits the 1, and then look what starts happening. All of a sudden, in our pattern, we go back to root 3 over 2. And then we go back down to root 2 over 2, and then down to a half, and then down to 0. So what happens is we start following the path exactly back down. So let me go ahead and write in these values here. So after a half, we have 2 pi over 3, 3 pi over 4. Once again, this is just a sketch. 5 pi over 6, and then pi. And then 7 pi over 6. Now, pretty much you would never have to write all of these values out like this for a problem. Most of the time, I just require that you write down the main ones, which I'll go ahead and highlight in a second. You could write them down if you wanted to. If you needed help with the graphing, that's what I would usually do when I was a student, or even now I'll still do that. So the main ones I would like to see on a graph are, not pi over 6, 0, half, sorry, pi over 2, pi, 3 pi over 2, and the 2 pi. These are the main ones. Alright. So now let's keep graphing this. So as we go ahead, plots down, it heads back down. So 3 pi over 4 is root 2 over 2. Then 5 pi over 6 is a half, and then we go down to pi. So it should be, and I did that kind of bad, it should be creating an arc. Sadly, this is sort of a hand-drawn graph, so it's not coming out perfectly. But if we had a nice, even graphing, we could see that it does this little arc. Then what happens is it starts to dip down. At 7 pi over 6, we go into the negatives. So we have a negative half there. Then we have negative root 2 over 2, which is about 7 we said. 0.7, and then 0.9, and then 1. And then it'll head back up in that little pattern that it has, and then it'll hit the axis. So that would be what we would call just one period of pi. So one thing you'll notice, though, is remember, we're talking about a circle. This thing is a circle. You could just keep going around and around and around and around on a circle forever, right? Which technically means sine and cosine do keep heading up or off in the other direction. Just sort of that wavy, sort of a wave, right? Just goes up and down like a wave. So usually we just talk about a certain period in the wave we're looking at. And most of the time, we keep between 0 and 2 pi. Alright, so that's what sine looks like. And the main important points to notice for sine that I find easiest for graphing, especially when we start looking at transformations, would be these ones right here. We have pi over 2, 1, 0, 0, 3 pi over 2, negative 1, and 2 pi 0. Alright, so that was sine. Now, remember the other one we look at is cosine. I'm going to go ahead and graph those in red. And those are our x values. So let's see. At 0, sine is 1. At pi over 6, sine is root 3 over 2. And then let's keep going. So then they're both root 2, then half, 0. Let's see, at 2 pi over 3, sine is a negative half. Oh, interesting, it's in the negatives, okay. Let me go ahead and write these down. I'll go ahead and pause the video, check back in with me in a second. Alright, so I plotted down my values. So let's go ahead and graph cosine. So I'm going to go a little faster this time because we already did this. So cosine is going to be at 0, 1. Let's restart there. And then it goes from pi over 6, it goes to root 3 over 2. So that's going to be, that's 0.9. And then they meet up right here. They're both root 2 over root 2. Then it goes down to at pi over 3, or half. And then at pi over 2, it goes to 0. So 0, oops, pi over 2, 0. Okay, so there's that curve there we have for cosine. And then it starts dipping down into the negative. So it goes to negative half. And then we go to the 0.7, which remember is the root 2 over 2. 0.9, and then we get to pi, negative 1. And then it starts curving back up. So you'll notice that's the pattern. They dip past, and then they curve up. And here we go, cosine, heading up. Boop. Pops up right here at 3 pi over 2, 0. And then it continues on. So at 5 pi over 3, what do we have? Let's go ahead and circle it. 5 pi over 3 is right here, and we're at half. So 5 pi over 3 half is about right up there. 7 pi over 4 is the root 2 over 2, which is about 0.7. 11 pi over 6 is about 0.9. And lastly, pi over 2 we have at 0. Sorry, at 1. And 1 right there. So let me go ahead and label that one 2 pi 1. So notice the main ones that I find are important is when we're at the 1s or the 0s. Okay, so it's those crossing moments. So that's cosine in red. And once again, cosine also continues off, because remember, we're talking about from a circle here of sort of endless opportunities. But those are the main sections that we'll look at for cosine. It does change a little bit because we look at transformations a little bit later, but these are the two main, you could say, parent graphs of the functions of sine and cosine. So this is cosine of t in the red and sine of t in the green. All right. Let's keep going. So for a period of sine and cosine have period of 2 pi. What does that mean? Well, it goes through one cycle in the length of 2 pi. So that's one cycle here of cosine, and then it'll just start repeating itself. Okay, once you've gone past that, it starts repeating itself. Same as for sine. So this is one cycle of sine, and once we get past this section, it starts repeating itself. So that's defined as sine t plus 2 pi equals sine t. And then for cosine, we have cosine t of 2 pi equals cosine of t. Let's take a look at example 2. Graph one period, or considered a cycle, of y equals negative 2 plus sine of x. Label key points. So usually what I'll have you do is each transformation, you'll graph separately on the graph, and we'll note the differences in the points as we go along. Normally, it's good to graph between 3 and 4 points for each graph, and usually I'll indicate that on an exam. So first off, let's start with the parent function, which is y equals sine of x. Now let's go ahead and plot the points, the main points for this. So sine of x, and then what are the y values? Or in our case, let's go ahead and do the x value, or the t value. Now let's keep calling it sine of x. So the main values we have are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Ran out of room here. Let me go ahead and erase this. Write it up a little bit higher. So what do we have? We had sine, and then the matching y values. So 0, pi over 2, pi, 3 pi over 2, and then 2 pi, which I said were the more important ones that I use when graphing. So the matching values, well, the y value for sine is 0, and then at pi over 2, what is y? I'll go ahead and reference it here. Pi over 2, y is 1. At pi, what is y. Y is 0. Then we have negative 1. And lastly, at 2 pi, y is going to also be 0. So let's go ahead and graph this. First, let me label out my points. So you have 2 pi, 0, halfway between is pi. And then we have pi over 2. And lastly, 3 pi over 2. Now let's go ahead and do the points. So 1, negative 1. So we start off with the normal sort of one cycle of sine, which goes from 0, 0. At half it goes up to 1, down to here, down to 1 again at 3 pi over 2, and then back up to 0 at 2 pi. And there we go. We have our main points. So for sine and cosine, more than likely, please label the 3 points. Sorry, the 5 points. It helps you keep track of the transformations. And then lastly, 0, 0. Okay, so that's the parent function, y equals sine of x. Next, we're taking a look at the transformation, which is, the only difference is that negative 2. So what does that negative 2 mean in transformations? Well, that is basically, we're going to go down 2 units. Okay, so vertical shift down 2 units. So all we do is we're going to go ahead and take our points for the vertical shift and take away 2 from the y values. So sine of x and then y. This is the negative 2 plus sine of x. So we have 0 and then the y gets minus 2. Pi over 2, and then we'll subtract 2 from the 1, so we get negative 1. Pi, subtract 2 from the 0, we'll get negative 2, 3 pi over 2. Subtract 2 from the negative 1, and we'll get negative 3. And then for the 2 pi, subtract 2 from 0, we get negative 2. Then we go ahead and label these points once again. 0, pi over 2, pi, 3 pi over 2, and lastly 2 pi. And let's see, we've moved down, so we're going to have to go ahead and scale this a little differently. We went down to negative, 3. We actually go down to negative 3. Let me go ahead and extend my graph. Alrighty. Now, let's go ahead and plot our transformation points. So we have 0, negative 2. Then we have pi over 2, negative 1. Then at pi, we're negative 2. Then 3 pi over 2, we have negative 3. And lastly, at 2 pi, we have negative 2. Okay, so once again, this is what I would expect to see for transformations on an exam, the amount of work. So labeling these main key points for sine, and there we go. We've graphed a transformation. It went down, vertical shift down of 2. So label the directions, and then label the points. Alright, now we're going to take a look at graphing one period of y equals negative sine x. I'm going to label the key points. So pretty much we always start with the parent function, which we already did do before, but for good practice, let's go ahead and graph it again. So for sine, what are the main values we look at? 0, pi over 2, pi, 3 pi over 2, and 2 pi. And the starting values for sine are 0, 1, what else did we have? Oops. 0, 1, 0, negative 1, 0. Let's go ahead and graph that. And plotting our points. So 0, pi, 2 pi, 3 pi over 2, and pi over 2. So I go ahead and graph the parent function. Check back in with me in a second. Alright, so I went ahead and graphed the parent function of y equals sine x, and now let's go ahead and figure out what the transformation is. Well, attached we have that negative, which means a reflection. And then the question is, where is it a reflection about? Well, that is going to be a reflection about the x-axis. So let me go ahead and write that down. Reflection about the x-axis. And let me actually just move that over real quick. So that's going to be a reflection about the x-axis. I'll leave that there so I have space to write my points. Okay, so what are our points going to look like? Well, we're going to multiply the y values by -1. So sine of x, those ones don't change. The y's will multiply by -1. Well, 0, that doesn't change. Ooh, but the 1 changes. That'll be a -1. Once again, the 0 doesn't change. Let's see. Ah, the -1 times 1 will be 1. And then 2 pi. And the 0, that doesn't change. So let me go ahead and write this down again. Multiply the y's by -1. That's just the hint of what we're doing. Okay. So when we do that, first let me go ahead and write in our values here. I'll pause the video and finish doing that. Now, let's go ahead and plot the points. So we have 0, 0, that stayed the same, didn't change with the reflection. Then we have pi over 2, ooh, -1, that did change, we have reflected. Then at pi, we're still 0. 3 pi over 2, ooh, we're at +1 now. And lastly, 2 pi 0, once again, that didn't change, because we just reflected about the x-axis. So all it did is it just sort of flipped our sign, and there we go. We have a reflection about the x-axis. Let's take a look at a few other ones. So now we're going to be using cosine. So we're going to graph one period of y equals 2 cosine of x, and we'll label any of the key points. Alright, so here we go, the parent function, y equals, actually, let me go ahead now, I'll keep using blue. Y equals cosine x is the parent function. We'll go ahead and start with the main values. So if we have, at 0, we know cosine is going to be +1. At pi over 2, cosine is 0. At pi, cosine is -1. 3 pi over 2, we get 0. Okay, so here's our values. Once again, you can reference the unit circle if you need to take a look at that again. Let me go ahead and label our graph and get back to you in a sec. Okay, so I went ahead and labeled my graph. Now let's plot these points. So we have 0, 1, pi over 2, 0, pi -1, and then we head back on up. 3 pi over 2, 0. Ooh, and I forgot one other value. Shucks, that's supposed to be, let me go ahead and erase this and fit it in. Forgot the 2 pi. So at 2 pi, cosine should be 1. There we go. Okay, so we have our 5 values. It graphs through, so it curves. So please note, it doesn't go straight down. It curves, so please note that on your graph. So even though you can't make it look exactly like the item, you should still be showing the curvature if it's curved. And there we go. Alright, awesome. So that's the parent function. Now let's go ahead and graph the transformation. So what is the transformation? Well, the main thing here is we have the 2 being multiplied outside of the cosine of x. So what this is it means that we have an amplitude of 2. So what will we do? Well, we're going to multiply the y values by 2. So let's go ahead and do that. So multiplying all the y values by 2, well, first off, let me go ahead and write down the usual pi values that we have here. And then we'll multiply the values by 2. So 1 times 2 is 2. 0 times 2 is just 0. -1 times 2, -2. 0, 0, 1, and 2. There we go. Alright, so let's go ahead and graph this. I'll plot my points in the middle here. So we have pi over 2, and then 3 pi over 2. Now graphing. 0, 2. Okay, so 0, 2, 0, pi over 2. Then we go down to pi -2. Then 3 at pi over 2, 0. And lastly, pi over 2, 2. Sorry, not pi over 2, 2 pi 2. So many pi's, it's hard to say them all. Alrighty, so there we go. Still want to make sure we can show that there's curvature going on. So here we go. And stretched upwards. So now it has become more of a stretched version, but it's still in the period of 0 to 2 pi. Notice that we're still within 0 to 2 pi. So our period hasn't changed at all. Let's go ahead and take a look at the next example. Example 5. Alright, so we have graphing the period, one period of y equals cosine of 2x. Oh, interesting. So the 2 this time is inside with the x instead of outside like we had earlier. So when it was outside, that was an amplitude change, so we multiplied the y values. Now we have the 2 on the inside, so how does that change? Well, first off, we're going to get really good at graphing the parent functions. So go ahead, pause the video, try graph the parent function, and check back in with me in a second. So once again, the parent function is y equals cosine of x. Alright, so I went ahead and I graphed the original parent function of y equals cosine of x. It has the period of 0 to 2 pi, and it's between 1 and negative 1. Now we have a 2 inside there with the x. So what does that mean? Well, this is going to be a period change. Okay? So we'll go ahead and introduce it in a second, but this is a period change. So at the moment, our period for cosine is 2 pi. And we'll take the value that's being multiplied to the x, which in this case is a 2, and we're going to divide our normal period of 2 pi by 2. And our answer is pi. So this is our new period. Really odd, but it's actually pretty easy if you follow sort of the method, I guess, that I'm going to show to you here. At least hopefully it makes it simpler. So now, what do we have? Well, I always just start with the farthest away point we have. So usually we start with 2 pi, but in this case we're going to start with pi. And then I'm going to half that. So I'll have pi over 2. And as usual, remember we always have the other 2 half points. So half of pi over 2 will be pi over 4. And then half of in between here, that's going to be 3 pi over 4. Okay, so once again, notice I have created a period of pi, but I still labeled the 5 main points. 1, 2, 3, 4, 5, just like we normally have 5 main points. So the only thing here that happened is we just squished the values. So what happened is our period affected our cosine sides. So it affected these values here. Okay, we basically ended up multiplying everything by half, which is sort of what we did here. So multiply the cosine x by a half. So that'll give me my new points, which I'll go ahead and write over here. So we're multiplying all the cosine values by a half, which is new because normally we just been multiplying the y values. So let's go ahead and write this down. So in this case, our y values don't change, so 1, 0, negative 1, 0, 1. But our cosine values change. So 0 times a half, that's still 0. Pi times a half is going to be pi over 4. Pi times a half is going to be pi over 2. Oh, I said that wrong. Sorry. Pi over a half times a half is pi over 4. Ooh, 3 pi over 2 times a half is 3 pi over 4. 2 pi times a half is just going to be pi. And there we go. We have the period I just drew down. So now let's go ahead and graph those points. So what do we have? Well, I forgot to label the ones. Here we go. We go 0, 1. And then pi over 4, 0. And then we have half, negative 1. Three pi over 4, 0. And then pi over 1. Sorry, just pi 1. You might say, do I really need to label all these points all the time? And the answer is going to be yes. This is definitely something I'll be looking for in your work. So pretty much, however I write down the work on the lecture notes, that is how or that is the way I will be looking for your work to be shown on exams. But if you ever have a question on how to show your work, please send me an email. Just go ahead and ask. It doesn't hurt to ask if you ever have any questions. So now look at example 6. We're going to graph one period of y equals cosine of cosine of x plus pi over 4, and label key points. Once again, we're going to start with the graph of the parent function, which is cosine. I'll go ahead and pause the video and write these down. Check back in with me in a second. Alright, so I graphed the parent function of cosine of x. Let's go ahead and graph the the transformation. So what is the transformation? Well, the only thing that's different here from what cosine normally looks like is we have that pi over 4. What is that telling us? Well, that is inside with their x value, which means we're going to be having a horizontal phase shift. Okay, so once again, these are drawing on the fact that you've worked with transformations in Math135. So if you haven't worked with transformations or it's been a while, just send me an email and I'll try to give you some resources for that as well. But once again, we're assuming that you have worked with transformations already coming into this course. Okay, so this is going to be a phase shift. So we're going to shift which direction? Well, we're going to be shifting, since it's a positive, once again, x's are weird, so it's going to be shifting left, pi over 4. Or you could say a phase shift left. Let me go ahead and write that down, phase shift. Alright, so we have a phase shift left, and let me actually move this down so I can write the points on the side. When we're phase shifting left, is that affecting our cosine value or the y value? Well, that's actually going to be affecting the cosine value because it's inside the parentheses. So if it's ever inside with the x, that's going to be affecting these values here. If it's outside of our cosine or the sine, it'll affect the y values. Okay? So since it's inside, it's affecting those cosine values. So what are we going to do? We're going to be subtracting pi over 4 from those values. Or you could say the t values. Okay, so subtracting that, well, we'll get negative pi over 4, and then pi over 2 minus pi over 4. Ooh, let me go ahead and zoom in on this so we can write this down. So we're doing pi over 2, and we're subtracting from it pi over 4. So to create the same denominators, we'll multiply top and bottom by 2, and we'll get 2 pi over 4 minus pi over 4, which gives me 1 pi over 4. Next we have pi minus pi over 4. Go ahead creating the same denominators. That'll be 4 pi over 4. Subtracting that, we get 3 pi over 4. And then we have pi over 2. So we have pi over 2 minus the pi over 4. Once again, creating the same denominators. So that's 3 pi over 2. Multiply the top and bottom by 4, so that's going to be, by 2. So that'll be 6 pi over 4. 6 minus that's going to be 5 pi over 4. Oops, I changed the color on accident. Let me fix that. And lastly, I'm kind of running out of space here. Let me move this down. Okay, so we have 2 pi minus pi over 4. Creating the same denominator, let's see. So we want a 4, and then that'll be 2 times 4, so that'll be 8. So 8 pi minus pi over 4 is going to be 7 pi over 4. Alrighty, so there we have our cosine values. And our y values have not shifted at all. Now let's go ahead and plot these points. Well, usually we have pi over 2 on this side. But for the sake of graphing, let's go ahead and do, so we have a negative pi over 4. Then we have pi over 4. And then there's going to be 5 pi over 4. And then 7 pi over 4. And then we go ahead and plot our points. Positive 1 up there. And negative 1. So once again, because there are no tick points on here, just make sure you have the basic graphing of where the points should be. I just realized I kind of labeled this wrong, so let me go ahead and fix that real quick. I forgot the 3 pi over 4. So that should be pi over 4, and then we have the 3 pi over 4, then the 5 pi over 4, and then the 7 pi over 4. Okay, I'll go ahead and graph these points. Check in with me in a second. Alright, so I went ahead and I graphed the points, and there we have the graph of one period of cosine shifted to the left, pi over 4. Now, let's go ahead and take a look at example 7. This is graphing one period of y equals 1/2 minus 3 cosine of 2x, and we're going to label the key points. Alright, so go ahead and graph the parent function first. I'll pause my video and check in with you in a sec. Alright, I went ahead and graphed the parent function y equals cosine of x, and you'll notice I set up the points a little bit differently. So this is another way you can set up the points. So going along the top horizontally, that'll be our pi values, or the t, and for the bottom values, those will be the y values. Alright, so I'll go ahead and let's see the next things that we have. So what are the different items we see along with cosine? Well, one of the main things that I'll see is I see that 2 by the x. So I know because there's a 2 in with the x, we're going to have a period change. What's something else I see? So another thing I see is that negative 3 outside of the cosine. And then lastly, I see that half. So it looks like we have 3 different things that are going to happen. So 3 different transformations. Alright, so for order of transformation, well, let's see. So the first thing we should do, we just note that we're going to need to change the period. Okay, so period change. So we'll take that item on the inside, so for the period change, we'll have 2 pi, which is the normal period, and we'll divide that by the 2, which means we have a new period, of pi. Alright, so let's go ahead and change that. So we have a new period of pi, which means that all of our original cosine values, the ones over here, I'll highlight them in green, all of these we're going to have to divide by a half, which is what we did before. So setting all those up, so we'll get 0, dividing by half, so we have pi over 4, pi over 2, 3 pi over 4, and lastly pi. So those are the new values there, and our y values do not change, because once again, the period change only affects our pi values. So I'm going to go ahead and graph that. I'll pause the video and check in with me in a sec. Alrighty, so I went ahead and I graphed the points for my new period, so we have a shorter period of pi. So that was the first transformation. Now let's go on to the next transformation. So the next one is the amplitude of 3. Oh, I forgot to mention this. We actually have 4 transformations. That negative is the other transformation. Sorry about that. So the 3 is just going to be one of the transformations. Once again, if you need any refreshers on transformations, please let me know. Alright, so squeezing all these values in here, what is the next transformation that we have? The next one is going to be an amplitude of 3. Oh, I already said that. Okay, so amplitude of 3. Getting a little squishy here. So what are our new values? Well, we still have the same pi values we were using before, because remember, we're always just slowly building upon them. And then 3 pi over 2, and pi. So an amplitude of 3. That means what we're going to do is we're going to multiply the y values by 3. So multiplying the y values by 3, we'll end up with 3, 0, negative 3, 0, and 3. Okay, I'll go ahead and plot this out. I don't need to do it full on to scale. I'm just going to go ahead and label this as negative 3 and 3. Then we have our pi over 2, pi over 4, and lastly 3 pi over 4. I'll go ahead and plot these points. Alright, so I went ahead and plotted the points, drew in my graph for the amplitude of 3. So now the next thing we have is, let's see, a reflection about the x-axis. So reflecting about the x-axis, what we're going to do is multiply the y values by negative 1. What I just realized, I do not have enough room here for all of my graphs, so I'm going to have to actually squish the reflection onto the other one right here. Sorry about that. So squishing the reflection. Ooh, running out of space. Reflect about the y-axis. Reflect about, the x-axis. So we're going to go ahead and multiply our y values by -1. Alright, so we have -3 this time, 0, +3, 0, ooh, and a -3. So that means it's just going to flip. So here we go, flipping our values. Once again, sorry that I did not have enough graphing on here. So writing in the new flip values, we have pi -3. 3 pi over 4 is 0. Still, again, I'll leave that in the yellow. Then on the top, we have pi over 2 +3. Same here for the two of them. And lastly, 0, -3. Alright, so that was the reflection about the x-axis, the other one. And lastly, what transformation do we have? We have in red the half. So that, since it's on the outside, that is going to be applied to our y values. So once again, anything on the inside is applied to your x values, or another way of thinking it would be your pi values. And then the values that are on the outside of the cosine are going to be shifting your y values. So we go ahead and write out the pi values again. And what did we say the transformation was doing? It's going to be shifting up by 1. By 1/2. There we have the half right there, shifting up 1. Okay, so that doesn't change our pi values. That's just going to change our y values, as I said earlier. Alright, let's see. So shifting up by 1/2, that means we're going to be adding a half to all these values. So that'll be -3 plus 1/2. That'll be -2.5. Then we have 0 plus 1/2, so that'll just be 0.5. And pi over 2 plus 1/2. Once again, I'm adding these values to the ones here because we're always building off of the graph previously. So let's see, 3 plus 1/2, so it's going to be 3.5. 0 plus 1/2 will be 0.5. And lastly, -3 plus 1/2, which we said earlier, -2.5. Alrighty, let me go ahead and plot these points. I'll add in the -2 for a bit more reference. And then here we go, we have the pi over 2, pi over 4, and 3 pi over 4. Okay. What color was I using? Let's do red. Okay. Let's see. So we have 0, 2.5 right there. Pi over 4 is 0.5. So pi over 4 is 0.5. Then pi over 2, 3.5. So up about there. And then coming back down, so 3 pi over 4 is 0.5. And lastly, pi -2.5. And here we have the finished version of our graph. So once again, you may not be given a graph with the perfect tick marks placed in. You might need to write them out as we've been doing before, which is why it's important to always label your points, because often that is what I will be grading. Definitely a lot of work. Alright. So note, when graphing trig functions such as y equals, and that's a typo right there, that should be sine of -x, or y equals cosine of -x, use the properties of even and odd functions to write y equals sine of x. Hopefully I fix this before you guys get this. Or y equals cosine of x, and then graph. So shifted sine and cosine. So this is something we were working on earlier. So if we have the graphs of y equals a sine k x minus b and y equals a times cosine of k x minus b with the k values greater than 0, we have an amplitude. You just take the absolute value of the number on the outside, period of 2 pi divided by k, which is what we did previously. Remember, we just took the value multiplied to the x and divided the 2 pi by that value. Next, we'll have a horizontal phase shift b. So whatever is inside with the x will be shifting right or left with that value. Alright, so when in doubt, follow the order of operations. However, it is usually easiest to change the period first. Any vertical shift up or down must be graphed, what does it say? Last. So vertical shifts up or down, graph that last. Let's take a look at example 8. Find the amplitude, period, and phase shift. Graph one period of the function and label key points. So which parent function are we using here? Well, it's y equals 3 times sine of 2x minus pi over 3. Okay, so we're talking about sine. So I'm going to go ahead and write down the transformations that I have first. So it's going to be y equals sine of x would be the parent graph. After that, let's see, what other items do we have that have been added to our sine? Well, we have that 3 out there. Then we have the 2. And lastly, we have that negative pi over 3. So what are all of these values? Well, matching these up with what we had earlier, a, so that's going to be our amplitude. Then we have that k on the outside, so that's going to change our period. Oh, interesting. And then we have the b value, so that's going to be our horizontal phase shift. Okay. All right, so we've found the 3 different things. So we have our amplitude, our period, and our horizontal phase shift. So after graphing the parent function, we're going to go ahead and graph the period, or the new period. So what is our period going to be? Well, it's always going to be 2 pi for sine and cosine, and then we'll divide by the value on the inside with sine, which was 2, which gives me the new period of pi. Alright, so go ahead and graph the parent function and check in with me in a second. Alright, so I went ahead and I graphed the parent function of sine. So now let's apply the period change. So the period change, once again, that's inside with the x value. So this means it's going to affect the sine values, or the pi values. So we're dividing them all by half, so it's going to be 0, pi over 4, pi over 2. 3 pi over 2 divided by 4 is going to be 3 pi over 4. And then lastly, 2 pi divided by 2 is going to give it pi. So there's 2 ways you can think of it. You can either think of it as being divided by the 2 or being multiplied by a half. There are 2 different ways to think of it. And then the y values have not changed. Okay, go ahead and graph those. Check back in with me in a second. Alright, so there we have the first part, so changing the period of our graph. Then let's go ahead and take a look at the next thing we're going to work on, which is going to be the phase shift. Oh, sorry, the amplitude. Amplitude of 3. So the amplitude of 3, what is that going to do? Well, that is going to be changing our y values. So we're going to multiply our y values by 3. So let me go ahead and write that down. So we have our sine of x, then our y values. Let me go ahead and copy them down. 0, pi over 4, pi over 2. Once again, not changing the pi values, but we're changing the y values. So 0 times 3 is just going to be 0. 1 times 3 is going to be 3. 0, 0, negative 1 times 3, negative 3. And lastly, 0. Whew, definitely an intense video. Lots of little numbers flying everywhere. Well, that's kind of math, isn't it? Okay, let me go ahead and change this. So notice, our values are going from negative 3 to 3. So I'm going to go ahead and make sure to label my tick points as such. And then... oh, that should have been pi over 2. My error. And my pen is a little slow too on top of all of that. Alright. Pi over 2, 3 pi over 4, and lastly pi over 4. Alright, let's graph these values. I think I was using green. Okay, green for the amplitude. So here we go. We have 0, 0. Then pi over 4, 3. Then pi over 2, 0. Then 3 pi over 4, negative 3. And lastly, pi 0. Let's go ahead and graph these points in. And there we go. Now, last one. I did once again forget a graph here, so hopefully I put that in for you guys on your notes. We have the last thing to do, which is going to be the phase shift of the negative pi over 3, which actually is going to be the opposite. So instead of a negative, we're going to be adding. So we'll be adding pi over 3 to our pi values. So we have a phase shift. Let me write that down here. Of pi over 3. And it's a subtraction, so we're going to go ahead and add pi over 3 to all our values. So we have our cosine. Sorry, we have our sine of x. And then our y values. So the y values, once again, do not change for this part. We're just adding the pi over 3 to our pi values, which, real quick, are these ones right here highlighted in yellow. So 0 plus pi over 3, that's easy, that's pi over 3. Then we have pi over 4 plus pi over 3. Ooh, let's do that on the side. Got to create the same denominators. So that's going to be 3 pi over 12 plus 4 pi over 12, which would be 7 pi over 12. I'll go ahead and add these all out. You can check back in with me in a second. Alright, so I found the values after adding a third to them. So I'm just going to go ahead and tick these values down. So we have pi over 3, 0. So this is going to be pi over 3. Then we know we're going to have 7 pi over 12. Then 5 pi over 6. Then 13 pi over 12. And lastly, 4 pi over 3. And these values go between negative 3 and positive 3. So let's go ahead and graph these. Which color was I using? I was using blue. Alright, the finishing graph in blue. Here we go. We're almost there, guys. Okay, so 0 pi over 3. And then we have 7 pi over 3, 12. Oops, up there. So that's going to be 7 pi over 12, 3. This was pi over 3, 0. Then we have 5 pi over 6, 0. And then 13 pi over 12, negative 3. And lastly, 4 pi over 3, 0. All right. Okay, so that is it for the examples here. Example 9 we're not going to be doing in this class. Alright, so that is it for our example. So if you go ahead, skipping this example, for graphing calculators, go ahead and plop these items into your calculator. I'll put the answers up on the Lima in the resources. I'll also put the answers up for the practice problem. Okay, once again, the practice problem is not a requirement in the course, not for the math in the summer class. If you're in the regular class, it will be required, but not the summer class. Other than that, that is it for 5.3. Please send me an email if you need any help.